Hello, good morning. Welcome to Sarasa Switad Suksa School. I am teacher Rolando, your mathematics teacher in grade 9. Our first topic is Unit 1, Surface Areas and Volumes. Here are some mathematical terms. Surface area, cuboid, prism, length, solid, isosceles, cross-section, volume, triangular, plane figure. Okay, thank you for reading. First, let's understand these two terms. 1. Surface area. 2. Volume. To understand better, please watch my short presentation. You might remember from your previous topic that the 2D shapes have both a 2D quantity called area and a 1D quantity called perimeter. Well, in similar way, 3D objects have both a 3D quantity called volume and a 2D quantity called surface area. Surface area is the area of the object outer surface or shell. Perimeter and surface area are both outer boundaries of geometric shapes. Perimeter is the one-dimensional outer boundary of a two-dimensional shapes, and a surface area is the two-dimensional outer boundary of a three-dimensional shape. And to help you see the difference between surface and volume, imagine that you have a perfectly thin box filled with ice. If you want to open the box, you can see that the 2D area that surrounds the volume, while the volume itself is the amount of 3D space occupied by the ice inside the box. So, surface area is the sum of the areas of all the faces of the three-dimensional figure. Example, a surface area of a cube equals 6 times side squared, while the volume is the amount of space it occupies. Example, volume of a cube equals side cube. Now that we understand about surface area and volume, let us discuss the first example of a 3D shape, which is a prism. A prism is a three-dimensional figure which has identical cross-section and all the faces are flat. Here are some examples of a prisms and not prisms. On the left side, we have a triangular prism, where both sides are triangle and the cross-section are identical, so it's called a prism. On the other side, we have a pyramid. A pyramid have a flat faces but the cross-section are not identical. Therefore, a pyramid is not a prism. Another example of a prism is a cuboid. A cuboid is a flat. A cuboid has identical cross-section and therefore cuboid is a prism. Now let's go to example of not a prism, which is a cylinder. A cylinder have the same cross-section, but the faces are not flat. Therefore, cylinder is not a prism. Did you understand what is a prism and not a prism? Some examples of prism are illustrated below. 1. Triangular prism, where both ends are triangle. 2. Rectangular prism, where both ends are rectangle. 3. Pentagonal prism, where the top side is pentagon and the bottom side is also pentagon. 4. Hexagonal prism, where both ends are hexagon. Now let's do some examples. Find the total surface of a prism shown, with a base of 3 cm by 4 cm. Here is the solution. First, you need to find the net of the triangular prism, which is the net is made up of 3 rectangles and 2 triangles. the back, the base, the front, and the two triangles. The area of three rectangles are 1. The back equals 2.6 times 4 equals 10.4 centimeters square. 2. The base equals 3 times 4 equals 12 centimeters square. 3. The front equals 3 times 4 equals 12 centimeters square. Then the area of two triangles. Since two triangles at the cross-section are isosceles triangles, the base of each triangle equals 2.6 centimeters square. Take note that we use a Pythagorean theorem to solve for the height of each triangle, which is a squared plus b squared equals c squared. Therefore, the height of each triangle equals the square root of 3 squared minus 2.6 divided by 2 squared. Then equals square root of 9 minus 1.69. Then equals the square root of 7.31. Therefore, the height of the triangle is equals to 2.7 centimeter. The area of each triangle equals 1/2 times base times height equals 1/2 times 2.6 times 2.7, then equals 3.51 centimeters square. But since we have two triangles, so we multiply 2 times 3.51 equals 7.02 centimeters square. Therefore, the total area equals area of three rectangles plus area of two triangles. Then equals 10.4 plus 12 plus 12 plus 7.02. Please pause the video to find the answer. Did you get the answer? Wow, very good. The total surface area equals 41.42 centimeters square. Now, consider a triangular prism. If we enclose it in a cuboid, we can see its volume is half of a cuboid. Therefore, volume equals 1/2 times width times height times length equals the area of the shaded end times length equals the area of the cross section times length. This is true of any prism. So we can conclude that volume of a prism equals area of cross section times length. Example number 2. Find the volume of the plastic block below. The side is 4 meters by 10 meters and the height is 5 meters. Take note that the volume of a prism equals area of cross-section times length. Here is the solution. Draw the cross-section of this block. The block can be thought of as a cuboid plus a triangular prism. Here is the diagram. Area of a rectangle equals 3 times 4 equals 12 meters square, while the area of a triangle equals 1/2 times 4 times 2 equals 4 meters square. Therefore, area of cross-section equals 12 meters square plus 4 meters square equals 16 meters square. Then the volume of a block equals area of the cross-section times length. Then equals 16 meters square times 10 meters square. Please pause the video to find the answer. Did you get the right answer? Wow, very good. So the total volume of a block equals 160 meters cubed. Now it's time to practice, because practice makes perfect. Now let's do some exercises. Exercises 1A. Number 1. Find the total surface area of A. An ice cube of side 6 cm. B. A cube of cheese of side 2 cm. C. A book of dimension 15 cm by 10 cm by 20 cm. Number 2. Find the total surface area of the following solids. First, triangular prism with a side of 4 cm and 11 cm. Second is a cuboid with a side of 12 inches, 15 inches, and 6 inches. Third, find the volume of each of the following prisms. First, triangular prism with a side of 4 meters, 6 meters, and 3 meters. The next one is a pentagonal prism with a side of 9 feet by 15 feet and the height is 12 feet. You can download these exercises on Google Slides and then print if you have a printer. If you don't have, just copy the questions and write in a piece of paper and take a picture and submit by email, line, or any other measures. Thank you for watching and see you again on our next lesson. Bye-bye.